Welcome. I'm making this video because many students have asked me to solve this particular question, which has appeared in the sahodaya papers. Okay. Well, they're generally considered to be a paper on the tougher side, but in fact it is not. If you know the concepts well, you can actually solve the question papers from sahodaya. Now, what is the question that I'm going to be discussing about? This is a 1-mark question that has been given to you from sahodaya. Let me read this question out to you. It is the second question, in fact, in 2016 question paper. It says find the angle between the lines. Okay, I'm supposed to be finding the angle between the lines, and the lines is defined to me something like that. X is equal to 1, comma, y is equal to 2. That's the first line. And then he defines another line, which is y plus 1 is equal to 0. And the other line is z is equal to 0. Right. Now these are two equations that's been given to me, and he's asking me what is the angle between the two lines. Well, this nowhere is looking like an equation of a line, isn't it? Because if I'm looking at the equation of a line, we have the vector form, which is this, right? This is the vector form of an equation of a line, right? And if I write this in the Cartesian form, it is simply x minus x1 by a is equal to y minus y1 by b, and that's equal to z minus z1 by c. This is something we already know, and this form is also called as the symmetrical form of an equation of a line. Okay, this is also called as the symmetrical form of an equation of a line. Okay, perfect. Now, what is the non-symmetrical form? Okay, to understand a non-symmetrical form, well, this is not there in your NCERT textbook, okay, and it's not even there in the R.S. Agarwal. It is certainly available in your R.D. Sharma. Okay, so let's look at this equation here. Okay, just one second, let me erase this. All right, perfect. Okay, so here I have two equations. Now, as soon as you look at it, you know that I have written equation of a plane here, isn't it? This is an equation of a plane. This also is an equation of a plane, correct? Now, obviously they both are equal to 0, but because I'm equating these two planes together, what I'm now representing is the equation of a line, which is the line of intersection of these two planes. Okay, now I'm going to show you a graph for this. All right, so this is the x, y, z coordinates which I'm showing you here. Okay, so I can see the x coordinate there, the y coordinate, and you have the z coordinates. So please keep this in your mind. All right, now what I'm going to do is to plot the two equations. Now that's the first plane that I plotted, all right, which is this one. Okay, now this was in blue color. Okay, that's what I just plotted, and then I have the other equation here, and that's in green color. Right, now that is in green on my graph. Right, okay, perfect. So if you look at this, you can see that these two planes are intersecting along a straight line. Right, you see that straight line there? Right, yeah, that's a straight line, correct? Now this equation of this particular straight line is been given to me. Clear? Okay, so this is the same diagram that I showed you on the other application. I've got this onto the paint so that I can actually draw something and show something for you. So the normal for this particular plane, something like that, and the normal for this equation is something like that, right? Correct? Though these two equations, do not look like they are perpendicular on this particular diagram. They are, or they might not be perpendicular. That's completely not required. But what I do know is that this line, which is a line of intersection of these two planes, okay, this line is going to be perpendicular to this line, and this is also perpendicular to that. Clear? Because this line lies on this plane and this line lies on this plane. Obviously, if this is perpendicular to the plane, the line, any line on this has to be perpendicular, right? Now, keeping that in my mind, if I'm taking this one as n1 vector, okay, if I'm simply saying that this vector, which is here, as n1 vector, and this is my n2 vector, okay, n2 vector. So I can just take the cross product of these two vectors, can I? Isn't it? I can just take the cross product of these two vectors. So once I take the cross product of these two vectors, what I directly will get will be the vector which is perpendicular to both of these vectors, which is simply going to be that vector. Okay, so let me go back to this application. I'm going to close this application. I hope you got what I was trying to explain to you. I'm just going to close that for you. Okay, I'm going to remove this picture. It's a very good application that I use to show these pictures to you. Otherwise, it's very difficult to actually perceive or imagine what kind of a diagram that we're going to get. Okay, perfect. Let me remove this. Okay, now let's go back here. Okay, so I'm going to play that on 3 dimensions so that you can have even more clearer picture of what I'm talking about. Okay, let's stop that. Now, perfect. Okay, so there are 2 different ways of identifying what are the DRs of that. One is just taking the cross product. The other is to take A, B, and C as the DRs of the required line. Now, because the DRs of the required line is perpendicular to both this a vector and that vector, I can take the dot product of this with this vector, which is 2 into A plus 3 into B plus 5 into C. That's going to be equal to 0, and that's going to be equal to 0 again. And I believe you know how to solve these 2 equations to get the DRs. You just have to take A, 3 into minus 1, minus of 1 into 5. And again, for B, you will always consider a minus B. So minus B, 2 into minus C, minus of minus 3 into 5. And you get the DRs. Okay. How do we find the point of intersection? Because when I'm trying to represent the line, I will need the point of intersection. What I've basically done is I've got the equation as x divided by minus a, some point, I don't know what that point is, and then I have a y divided by y minus something divided by 17, and that is in turn equal to z minus of something divided by minus 7. Now, I'm not going to get into finding out this particular point, okay? We don't need that. Okay, so which means that the equation that I have, which is that x minus 1 equal to 0 and y minus 2 equal to 0 is the first equation. So let's now find out how this particular planes look on the 3-dimensional graph. So I had x equal to 1 and y equal to 2, correct? X equal to 1 and y equal to 2. X equal to 1 has not been drawn. Yeah, there. So let me go back. X equal to 1, y equal to 2. So now when I see these equations, you see that this is the x-axis, the one here, and then the y-axis, and then the z-axis. So you see, they both are planes perpendicular. One is perpendicular to the zy plane, and the other one is perpendicular to the zx plane, isn't it? So that's the plane for me. but they intersect along a straight line. And if you actually notice this, that particular straight line is perpendicular to the y-axis. It is also perpendicular to the x-axis. What it is parallel to is the z-axis. True? Let me just stop that. Okay, so you see that's the z-axis, and this line, right, is parallel to the z-axis. So what are the drs of the z-axis? Whatever is the dr of the z-axis is simply going to be the drs of the required line, which is going to be cos 0, isn't it? The drs are going to be cos 0, because the angle that it's going to be, oh sorry, the angle that it's going to be making with the x-axis is 90, right? That's the line. It's making a degree of angle of 90 degree with the x-axis, an angle of 90 degree with the y-axis, but with the z-axis the angle is 0. So cos 90, we know that it's 0, and cos 90 again is 0, so cos 0 is going to be 1, right? So the drs are going to be 0, 0, 1. Correct? And if I'm looking at that equation, which is y is equal to -1 and z is equal to 0, let's go back and plot that. Z is equal to 0 and then y is equal to -1. Now if you analyze this graph again, okay, now if you see that this particular line, right, and that's the line which is perpendicular to the z-axis, it is perpendicular to the y-axis. What it's parallel to is the x-axis. So I'll have cos 0, cos 90 and cos 90 as the drs. So cos 0 is a 1, so the dr of that particular line is going to be 1, 0, 0. Correct? Now if I'm trying to find the angle between the line, which these as my drs, what am I going to get? The angle between the lines, which is defined as the cos theta, right? So cos theta is simply going to be equal to dot product, isn't it? So that's 0 into 1 plus 0 into 0 plus 1 into 0, and that's divided by, no matter what that is, in fact this is going to be root of 1 into root of 1, which is also a 1. So this, the numerator is a 0, so basically I'll have a 0. So what is the angle between the lines? The angle between the lines, which is cos 0, is going to be, cos theta is going to be 0, which means theta is equal to 90. Now let's go back to the diagram here. I'm going to draw all the 4 planes, okay, and I'm going to try and get the equation on this. I hope I can do that. 1 and then 2. Okay, now you will have to imagine this. The line of intersection is that, isn't it? You see, that's the line of intersection of the first 2 planes. I'm going to remove that and show that to you. 1, 2. So 1 and the other plane comes in there, and that's the line of intersection, and that's the same line of intersection for this also, right? And now I'm going to remove the other 2 planes. So now when I introduce that back, I get 1 and 2. So you see that that's the line which is perpendicular, right? And it completely makes sense of what I'm talking about, isn't it? So this is the explanation for the question that has been given in sahodaya paper. It's a 1-mark question, but a very good concept behind this particular question. I'm glad I could actually find an application where I could plot these particular equations to you and show that to you in diagram, and I hope you understand how exactly it's been done. Very good video. Please go through this video, share it with your friends, and probably you can subscribe to this. And if you have any suggestions on or any particular question that you want me to do, let me know. I will update that for you. Okay, thanks a lot and goodbye.